a practical introduction to SPSS and R. Yesterday, we had a wonderful webinar with Mr. Ebenezer, and today we are having our R section with Mr. Ajay Chain. First of all, I'll give a background for this webinar, then a brief introduction of our speaker, then he'll take over and start his presentation. Last 6 months ago, I had a section with Mr. George Ajay on the conference, I think organized by Institution Ghana, and he taught us how. He actually gave us how, and from then I've kept in contact with him. I've been on his webinars here and there. And I can say that Mr. Ajay is a very passionate and avid presenter on this particular topic. He's a passionate civil and environmental engineer and a data science enthusiast with a keen interest in intersection of engineering and data analytics. He holds a bachelor degree in civil engineering from KNUST and a master's degree in environmental engineering from UMass. George is currently a PhD candidate in coastal engineering at University of Cape Coast, where his research explores sustainable water management, coastal structure environment, intersection, and the use of machine learning and artificial intelligence for environmental sustainability. With a solid foundation in both engineering practice and statistical analysis, George has served diverse roles, including site engineering, operations officers, and assistant engineer across top civil engineering firms in Ghana and China. His practical experience spans structural waste, supervision, water waste treatment, and quantity surveying. Mr. George is an ardent user of R programming with a focus on statistical inference, data visualization, machine learning, and predictive modeling. He actively contributes to the Ghana R user community and co-facilitates research and data analysis training sessions, equipping researchers and students with industry-relevant data science skills. In his free time, Mr. George enjoys exploring new technologies, watching action movies, and mentoring young professionals in research and analytics. His sessions are engaging, as I said earlier on, and very practical as well, and filled with insight that bridge academic theory with real-world application. Without much ado, please with various emojis and reactions, let's welcome Mr. George Ajay Chain.
Okay, Godfrey. Thank you very much for your introduction. So my name is George. As he said, I'll be taking you through today's session. So today we are looking at an introduction to the R programming software. Yesterday we looked at SPSS. So my colleague Eben took you through the SPSS program and then how you can analyze your data using the SPSS program. And today I'm taking you through R. I don't know if you can see my screen. Can everybody see my screen? If you can see my screen, just give me a thumbs up. All right. Okay, then let me go into presentation view. Okay, so as you already know, this is a collaboration between the Elite Research and Data Science Institute and then the Federation of Ghana Medical Students Association. So it's a 2-day webinar, which we've already explored the first day, and we are continuing today for another session. So I'm sure you already know Mr. Eben, who took you through the SPSS, and myself, I'll be taking you through R. So today's topic is just the basics. I'm sure most of you are new to the R. Others too have maybe heard of it or maybe used it before. So I wouldn't be doing anything strange or anything out of the ordinary. So I'll keep it simple so that we all understand and then apply it in our data analysis. All right, so the objectives for this session, ideally, I would want you to understand the house ecosystem, how to load in your data. That is after you have done your data collection and all that, how to load it inside, how to start your analysis. So how to manipulate and then visualize the data, how to get some simple summary statistics, run some basic models. So when I say basic models, like simple inferential statistics. And then the final one is to produce a reproducible report. But maybe I'll skip that one because that one is a bit advanced for beginners. So I think the first four will do for now. And maybe when we get the chance another time, I can take you through the last one. So I would like to do a small introductory of the R programming language using these PowerPoint slides before I go inside the software itself and then explore the software so that you all know what it entails. Now, before this, we shared a file with you on a Google Drive, which contained the R software and then the data that we'll be using. And I am sure by now, most of you have already installed it. So I shared the Windows and then the Mac version. So I'm sure by now, most of you have installed it. So those that haven't installed it too, maybe you can do it another time. But I want you to follow closely what I'll be doing so that in your free time, also the session is being recorded. So after the session, maybe in your free time, you can watch the recording and then follow along. Now, yesterday you saw how to use SPSS and how simple SPSS is. But then there are certain drawbacks in using SPSS where R fits in better. The first one is R is free, right? R is free. And then it's open source. So when we say open source, it means it is allowed for developers to add or modify its content. So a lot of people create something we call packages, and then they are shared or they are assessed by the R developers whether to accept it or not, and then they add it to the R ecosystem. So it is open source, so anybody can do anything with it. But it also has a license that you have to follow. So the fact that it is free doesn't mean that you can use it for anything at all. But the emphasis here is that it is free, but SPSS is not free. You need to pay for SPSS. So this is one benefit that R has over SPSS. And then another one is R has over 20,000 plus packages. So when I say packages, they are just a collection of functions that helps you to accomplish a certain task, right? So SPSS can do certain types of analysis. So any analysis that SPSS can do, R can do. But then there are certain analysis that R can do that SPSS cannot do. All because of its package ecosystem. So there are a lot of packages. So even if you want to create a website, There's a package in R that can help you to do that. If you want to create a blog post, if you want to create a book that you can host on a web, R can help you to do that. So it has a lot of things that you can do apart from statistics, right? Okay. And then another part is that it has a strong data wrangling ability. So when I say data wrangling, it means sometimes you have data. Maybe you prepared your data in Excel, right? But when you load it into R, sometimes you need to do some adjustments or modifications regarding the type of analysis that you want to do. So depending on the type of analysis, maybe you need to change some variables or the shape so that it will fit perfectly in the type of analysis that you can do. And R contains or has a package that you can use to do that. So the widely used package for that is found inside the tidyverse. So the tidyverse is like a collection of packages, right? It contains different types of packages for data wrangling. So you can create subsets of your data. You can filter your data according to certain conditions. You can add or modify columns. You can select a particular aspect of the data for certain analysis. So that is what the data wrangling is all about. And then yesterday, we saw that the graphs or the plots that were produced in SPSS were not too pleasant or like publication ready. But in R, you can see the plots here. They are very beautiful. So this, you can do this in R. This looks publication ready. So you can do all these plots in R, and then it will make your work look very nice and publishable. And then the next thing is the reproducible workflow that I talked about. So the reproducible workflow has to do with reporting or communicating your analysis. So let's say you've done your analysis and then you want to share it. How do you share it? You just copy the codes like that and then send it to the person that I want to share it with. How will the person even work with the codes? How will the person understand the codes? So there's something in R that we call Markdown. So the Markdown is an interface that combines code with simple text or normal text and then pictures. So you can combine all those things to create a beautiful document. So you can create a Word document, you can create a PDF document, or an HTML document. So an HTML document is hosted on the web. So you can create a PowerPoint presentation. You can create a PowerPoint presentation or a website blog, all using the Markdown. So this helps you to share your work for others so that they can also look at it and also do something. Or if they want to maybe replicate your work, they can look at it and then replicate your work. So those are the benefits of using R. So the first one is it is free. The second one is it has a lot of packages. And then the third one is that it can be used to produce publication-ready graphs or plots. So there are a lot of other benefits, but these are the benefits that I think are relevant. Okay, so I wouldn't be going through the installation process. So you already have the files, right? So the installation is not too difficult. Just click on it and then follow the instructions, and then you will be able to install it. Now, this here, so I forgot to say this. The files that we shared with you in the R software folder, there are two files. One is the R software, and then the other one is R Studio. Now, you need the R software in order to use the R Studio. So the R Studio is an IDE. or an integrated development environment, which makes using R very simple. So this picture that you see on my screen here, this is the default R interface, right? This is the default R interface. When you open the R, so when you install only the R and open the R, looks like. And sometimes it's difficult working in this console because when you are typing and you make mistakes, it wouldn't tell you anything unless you run it and then you get an error before you know that you made a mistake typing. So we hardly use the default R interface. That is why we use the R Studio. Okay, so those that joined today, I think Godfred will share the link in the chat so that you can go there and then download the files. Okay, so this is the default R Studio. We don't normally work here. You can equally work here, but we don't normally work here. So this is called a console, where you see a greater than sign, and then you see a cursor blinking with this information here. This is called a console. So this is where you type your code, right? Any command that you want to execute, you type it here. All right, then we go to the R Studio. So this is how the R Studio looks like. So the R Studio has 4 pins, right? So when I say 4 pins, it's like windows. You have 4 windows here. And then at the top left is the script. So at the top left, you type your code there. At the top left, you type your code there. It is not the console, but you can type code there. It is called a script. So it's like a file or a Word document or a text document where you type your text. So it's like when you open your Word document, the page that is open to you, this is what the script is represent. So it's like a blank page where you can type your code and then save it. So in the script, you can type your code and then save the code. But in a console, so below the script, right beneath the script, is what we call the console. So there you see this greater than sign and a blinking cursor. Here you can type code here, but you cannot save the code in a console. So if you want to type code and save it, then you need to do it in a script. But if you just want to run some commands and then see the output, then you do it in a console. And then in the top left here, sorry, top right here, we have our environment. So here, variables that you declare in a console or in a script, you see them here. Data sets that you import, right? You see them here. So any variable that you declare or any objects that you declare in a console or in your script and any data, you see it in your environment. So there's also a tab within this pane. There are like 4 or 5 tabs. So there's a tab called history. This history tab shows you all the commands that you have run in your console, all the commands that you have run. And then the connections, this one has to do with connecting a remote database. So it's like SQL. So I wouldn't talk much about that. And then the build and then the git is for version control. And below that is your files and then a plot. So here, the files is like the working directory. So anytime you open R Studio for the first time, it is being open, or the items that you are working with, they are being saved in a folder on your laptop or on your computer. So for Windows, the default folder, like for storing these items, is the document folder. And then for Mac, I think it is root or something. Root, I don't know, but I think it is root user or something. But for Windows, it is the document folder. So you have your files tab here, and then a plot. So the plot tab is when you draw a plot or when you write code to draw a plot or a graph, it will show in the plot tab. And then the packages is all the packages that you have installed in your R environment. So the help is also some information on any function that you want to know. So there are also tutorials. So R or the R Studio also has inbuilt tutorials. So if you want to learn the R, you can click here and then look at some of the tutorials. And then the viewer. The viewer is for let's say Markdown or HTML output. So when you write code to create an HTML output, it will be open in the viewer tab, right? So it is different from the plot tab. So if you write a code to draw a plot in an HTML output, it will not show in a plot, it will show in a viewer tab, right? So this is just a brief explanation of how the R Studio interface looks like. But then I'll show it to you in real time when we are doing the practical aspects. Now, in order to be able to use R, there are certain terms that we must understand or certain terms that we must know, right? And one of them is the syntax or the grammar that R understands. So the syntax is like the way and manner you should present your code such that it will not give you an error. So R, anytime you are typing code in R, make sure that the code, like the alphabet or the codes I type, they are uniform. As in, if you are typing in capital letters, make sure that it is consistent. So if you use capital letters and then later on you come and use lowercase or small letters, it will give you an error because it will tell you that it does not know what you are trying to say. Because previously you told it that, let's say, boy, you spelled boy with capital B, and then now you are spelling boy with small b. It will tell you that it doesn't know there's boy with small b because initially what you told it was that boy is capital B. So R is case sensitive. And then if you want to write code, mostly there's something we call comments. You can add comments to your code. The comments help you in future, right? Initially, you wouldn't see the benefits, like you wouldn't see why should I add a comment. But I advise you that anytime you write code, you make sure to add a comment because you might come back to that code in the future and then you will be wondering, hey, this code, what was I trying to do? Once you add a comment to explain what the code is doing, anytime you come back to the code, you know that, oh, okay, so this code was doing this code was doing that. Then it kind of refreshes your mind. And to write a comment in R, use the hashtag, this symbol. So once you begin a code with this symbol, it is considered as a comment and it is not run as a code. If I write my code and I start with hashtag, even inside the console and I run it, it will not run because it is starting with a hashtag. So our studio understands that a hashtag means a comment. So it will not run it. So you can write anything at all after this. So you can write a long sentence or a short sentence or a single word. It will just ignore it because it knows it is not code. It is just a comment. And then R also executes codes line by line. So you should write your code line by line. So you cannot write the code like you are writing a sentence or writing a paragraph, right? There's a syntax for that. So know that any code that you write, it is being executed line by line. So it starts from the first line, then the second line, and the next line, like that. So even if you write a code about 20 lines, know that it will not run all the code at once. It will start from the first line. So anytime it encounters an error in any of the lines, it will abort. And then it will tell you that maybe at line 2 or at line 5, blah, 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 there's an error. So you know how to handle it. Okay. So here is an illustration. So here you see that this is a comment. I started with a hashtag. So this is ignored. This is a comment. It is not run as code. So here, what you see here is a console. So I do print. So print is a function that prints the output of anything that you put inside. So when I do print hello world, so this hello world is a text that I want to print. So you see that this is code. So it is showing me the output, hello world, like that. So the one here is the index of the hello world. It is only one. So it means this is the first item here. All right. Then we move on to variables and then data types. Move on to variables and data types. So variables store data, and then the data types are the data that are stored in the variables, right? So for the paper or the article, the data that we are going to use, the variables are the headers, right? I'm sure you all have the Excel file. So in the Excel file, the variables are the headers. So when you see, let's say, study group, vitamin D status, or non-vitamin D fortified status, those are the variables. So the column names are the variables. So variables ideally are used to store a particular data types, right? Variables are used to store a particular data types. And in order to store a data in a variable, you need to use this symbol here. So you can either use this symbol or this symbol. So you can either use, this is less than, and then a hyphen, and this is equal sign. So you can either use this or this. So this is called an assignment symbol. It is called an assignment symbol. So let me show you how it works. So you see here, this is the variable var1, and this is the data 20. So var2, so you see that I'm using this symbol, the assignment symbol. It means I want to assign the value 20 to this variable. Here also I'm assigning the data name to this variable. So mostly the variable is on the left side and then the data is on the right side. So once you type code like this, you will not see any output. If you type code, let's say you are assigning a data or a value to a variable and then you run it, you will not see any output. If you want to see the output, all you need to do is just call the name of the variable. So if I say var1 and I am assigning 20 to it, when I run this code, I will not see anything. If I want to see what this variable contains, I'll just type var1 and then it will show me 20. Or I'll just type print var1 and then it will show me 20. Okay. So the data that I was talking about, you see that here I have 20 and then I have name. Now these two, they are all data, but they are different types, right? You see that this is a number and this is a text. So this is a different data type. This is also a different data type. Now, how can handle various data types? So the data that we saw, the 20 is called a numeric data type because it is a number. And then the name, which is a text, it is called a character data type. So character data types are text, right? Or words. But in order for us to recognize them as text or words, you need to puts them in quotation marks. So you see that the name here, it is in quotation marks. So it can either be double quotes or single quotes. It doesn't change anything. So you see that here R is great. I put them in quotation marks. So here, when I type it in a console, R will recognize this as a character. And then the numerical data types are just numbers. So it can be a decimal number or an integer. They are all numeric. And then there's other data types, which is logical. So the logical data type, we have true or false. So there are only two types, true or false. So the logical is like a Boolean operator. And then we have factors. So the factors are for categorical data. So yesterday, you saw that in SPSS, you can have nominal, ordinal, continuous data types. So in R, the continuous data types is the numeric data. And then the nominal and then the ordinal. Those are factors, right? So factors in R means categories. So you see that we have male and female. These are categories. So when you import a data into R using some functions, it will automatically guess the type of data. But if you want to specify the type of data too, you can specify it. So student age. So here I am assigning 19 to student age, right? Here, this is a numeric variable. So student age is a variable, 19 is the data. So 19 is a numeric variable. So you know that 19 is also an integer. So if I want to specifically say that I want 19 to be an integer, I can do that. But by default, it is stored as a numeric variable. Then student name. So student name, I'm saying Kim Promise. So this, because it is in quotation marks, R automatically recognizes it as a character. But then if I want to change it to a category, right, I can do that. So the factors, they are not guessed automatically. So the factors, you need to intentionally specify it yourself. But the character, the logical, the character, the logical, they are guessed automatically. But for the factors, so you see here, you see this last line of code here, student groups. So here you see that I am specifically stating factor, right? So factor, and I have first year, second year, third year, final year. Now you see that before specifying all these items, I brought a C, right? I brought a C, and then I brought a bracket, and then I put all these words inside. Now the C, what the C is doing is, it is bringing together all these items. So far, what you have seen in assigning data to a variable is that we are assigning only single data types. So this 19 is just a single data. This Kim Promise is a single data. Has hostel, true. This is also a single data. Now, if you have more than a single data, so let's say student ages. Let's say you have a variable called student ages. So ages mean more than one. So it means you want to store more than one age in this variable. Then what you need to do is, before typing the numbers, you need to start with a C, and then you open your bracket, and then you type all the ages. So when you type the ages, you separate them with a comma. So the C is like bringing everything together into a single item. So when you do that, we call it creating a vector, right? So we will look at that in a practical aspect. We'll look at that. So this C here is used to create a vector. So this whole thing here is a vector. But then when I specify the factor, it means I want it to be categorized. So you see that when I run this, there will be another output telling me the levels or the categories. So I'll see level, and then I'll see all these things. Okay. All right. So I explained the vectors. I explained the vectors here. So here I told you that this is a vector. Now, there are different data structures. So a data structure is like an item that stores different data, right? So if I have, let's say, a collection of data, then it becomes a data structure. But if I have a single data, it is just a data, right? But if I have a collection of them, so let's say I have student names, so I have a collection of names, then it becomes a data structure. Now, the main data structures in R are the vectors, the matrices, the list, and then the data frame. So the table is just another version of the data frame. But these are the main data structures in R. So the vector, as I said, is a collection of a single data type. So you can have, let's say, a collection of names. So maybe Kofi, Ama, Kojo, Ajoa, Kwabna. And I told you that before you can create that, you need to start with C. So type in all the names are characters. So you put them in quotation marks. You separate them with a comma. And then you start with a C before the bracket, so that R knows that it is a vector. And then for a matrix, I think we all know what a matrix is. We are university students, so we know what a matrix is. So a matrix is a two-dimensional data or a two-dimensional structure which contains data. So the data could be numbers or characters or logical values. Now, for the vectors and then the matrix, they can only contain a single data type. So you cannot create a vector that contains numbers and then characters. Or you cannot create a matrix that contains numbers and characters. You can only create a vector that has only numbers or a vector that has only characters. The same thing goes for the matrix. But with a list, so you see these images are representations of the structures. So there's an array. So the array, I'll not talk about that. The array is so the matrix is a two-dimensional data structure. The array is a three-dimensional structure. So I'll not talk about the array. I'll talk about the list. So the list can contain all these types of data structures. So the list can contain a vector, it can contain a matrix, it can contain an array, it can contain a data frame, and then it can also contain another list. So the list is like the mother structure, which can contain any type of structure. And then we move on to the data frame. Now, the data frame is what we see, or the data structure that we normally use in our everyday analysis, right? So the data frame, you see the data or the tabular data that you have in our Excel. That is what the data frame is. So the data frame is just like data in Excel. So the data frame can contain data of different types. So it can contain a numeric data, it can contain a character data, it can contain a logical data. So it can contain all types of data. So the data frame, the array, the list, they can contain different types of data. But for the vector and the matrix, they can contain a single data type. Okay, so here is an example. Here's an example. I have a vector here. You see that I'm starting with C. So the C means combine. So I'm combining A, B, C to create a vector. So A, B lectures to create a vector. So this is a character vector. You see that all of the items here are characters. And then a matrix. So to create a matrix, you use the matrix function. To create, this is a DF. So table, this is a data frame. So I will not talk much about this. I don't want to confuse you. So we'll just focus on the data that we are about to do, or the analysis that we are about to do. So this is just to introduce you to the R environment or the R ecosystem, so that you are familiar with certain things, so that when I am doing the analysis and I am saying certain items, then You have an idea of what it is. Okay, so this is how you create an array, and this is how you create a list. All right, now to importing data. Before you can do any analysis, as I said, you need data. Sometimes you can type the data directly in R, but because this is coding, and then human beings are prone to mistakes. So here, we mostly advise that you prepare the table somewhere, either in Excel or any software that you have, and then you import it into R, right? So to import the data in R, there are certain packages that you need to have. One is called readr, and then the other is called readxl. So this readr is used to import CSV files, TSV files, tab separated files, comma separated files, and then other file formats. And then the readxl is used to import Excel files. So Microsoft Excel files can import using this. And then there's another package called Haven. So HAVN. Let's say you have data in SPSS and then you want to import it into R. You can use the Haven package. So the Haven can import data from SPSS, Starter, and those other softwares into R. But here we'll be only looking at the readxl because we'll be importing the data from an Excel file. Although we have the SPSS file, I'll not use that one. I'll use the Excel file that we have. Okay, so this is how the syntax looks like. I think, yeah, this is how the syntax looks. So before you can use any package, right? Before you can use any package in R, some of the packages are pre-installed. So there are some packages that come pre-installed in R. These are not one of them. So you need to install them, and you need internet to do this. So just type install.packages. You type the name of the package in quotation marks inside the bracket, and then you run it. You will see some output telling you that looking at blah blah blah, and then it will do its thing, and then it will tell you that package successfully installed, blah blah blah. Then you know that the package is installed. Once the package is installed, if you want to use it, you use this function to load the package. Now the package is installed, it is somewhere resting. If you want to use it, you use this function called library. So the library will tell the package that, hey, you are needed, so come. So it will load the package in your current environment. So once you load the package, that is all. You don't need to load it anytime you want to use the package. So if you load it once, that is all. You don't need to load it again. So any package that you need to use, you use the library function to load it. So once you have loaded your package, then you can use functions inside the package. So I told you that a package is just a collection of functions. So functions are codes that help you accomplish certain tasks in your analysis. Now, this read CSV here, this read underscore CSV, this is a function. So this function is found inside this readout package. So without this readout package, you cannot use this function. So that is how R works. There are certain functions that you need from certain packages. So in order to use those functions, you need to load those packages. So this is one of them, read CSV. And what you need to input, or the argument for this, is the location of your file, right? So remember I told you that once you open RStudio, it is open inside a folder on your machine. And by default, in Windows, that folder is my documents. But in Mac, I think it is root or something, but I'm not sure. I use Windows, so I'm not sure about the Mac default location. So in order to read a file, you need to put that file inside that folder, right? And then you call the name of the file like this. So if the file is named my data.csv or my data.xlsx. You use the name of the file. That is all. That is the only required item that I need to specify in this VTS. So the show column types is an optional argument, which is not necessary. It is optional. This is the only required argument that you need to specify. The location of your file. So I'll show you if the file is not inside your directory, the folder where you are working in, I'll show you how to get it and then load it. So you use this function called head, and then you can see the output. So you see that here I have loaded the data. So this is how the data looks like. So this output that you see here, this is the data frame, right? So the table here is just another name for the data frame. So this is the data frame. The table presents the data in a different format, but then there's not too much difference between the table and then the default data frame. All right, so we've seen how to import data. The next thing is how to manipulate your data, right? So once you have imported the data, the next thing is you inspect the data and then you see if everything is as expected, whether I need to make some changes, whether I need to add some things, whether I need to filter out certain items. This is where you do it, the data wrangling. So you can filter, you can select, you can mutate, you can summarize. And then the package for this is called dplyr. So you saw that for the import, we have the readr and the readexcel. And then for the data wrangling, we have dplyr. So these are some functions inside the dplyr package. So filter is to subset rows on a condition. The mutate, you can add or modify a variable or a column. And then the arrange is used to sort your data, whether in descending or ascending order. And then the select is to select specific columns or variables. And then the summarize is to aggregate. So you reduce multiple values down to a summary. So let's say you have a study group, and then you have their vitamin D, how do you call it? Their vitamin D content. And then let's say you want to find the average of the vitamin D content in each group, then you can use the summarize. Mostly, the summarize goes with the group by. So it groups data for performing operations on subgroups. So when you group the data, then you can reduce it down into a particular summary. So the summarize and then the group by, they go hand in hand. And then another package that you can use for data wrangling is called tidyr. So the tidyr also provides some useful functions. So there's a function called pivot wider, pivot longer, unite, and then separate. So the pivot longer makes a wide data longer. So let's say sometimes the data that you have, let's say you have name, let's say you have students data, right? And then so you have name, the name of the students, and then let's say you have class of the students or the level of the students. And then you have, let's say, subject. So each subject, you create a variable for each subject. So let's say English, you create a variable for English, you create a variable for maths, you create a variable for science, you create a variable for any other subject. That is called a wide data. Now, if you want to group all the subjects into a single column or a single variable, it is called a long data. So all the data, like all the variables or all the columns, you want to aggregate them or reduce them into a single column. So let's say all the subjects. So I have math, English, science, geography, blah, 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 about 20 subjects, all as variables or all as columns. Then that data is a wide data. So if I want to gather all of them into a single column, then I am making the data longer. That is where we use the pivot longer. So you can pivot longer and then you can pivot wider. So it depends on what you want to do. So the pivot longer and the pivot wider, they change the dimension of your data or your data frame. And then the separate splits a single column into two. So let's say you have a column, right? Let's say you have a column full name, right? So the column full name has the full names of students. Maybe you don't want it like that. You want first name and then last name. So you can use the separate to split that full name column into two separate columns. So let's say I have Kingsley Abebio, right? Kingsley Abebio is the full name. Now I want to split the Kingsley Abebio into two columns. So I use separate. So I have Kingsley as the first name and then Abebio as the surname. Sorry, as the last name. So the unite, that's the opposite of the separate. So let's say you have first name and last name, and then you want to combine them into a single column as full name. So you see that the pivot longer and then the pivot wider, they work opposite, and then the separate and unite, they also work opposite. So there are other functions, but these are the ones that might be relevant to you. So there are other functions inside the tidy. And then inside the DPLR2, there are a lot of functions. But the ones that we mostly use are these ones. And then the next is, so now we have imported our data, right? We have cleaned the data. So we have done some manipulation and some wrangling. So we see that, oh, okay, now the data is ready for visualization, or the data is ready for analysis. Sometimes before you do analysis, you first have to do some visualizations to see maybe some relationship before you decide on the type of analysis that you need to do. And the visualization is just creating a graphical representation of your data. So sometimes looking at the data raw like that, you might not see certain patterns. But once you decide to create a graphical representation, it can show you certain patterns that are not readily available in the raw data frame like that. So we use a certain package. So we use a package called ggplot2. The ggplot2 package helps in data visualization. So there's a base R function for making plots, but the ggplot2, you remember the plots I showed you previously? They were made by ggplot. So they help you to create publication-ready plots. And then they work by following a layered approach. So you plot graphs layer by layer. So I'll show you how to do all that. It will be very interesting. I don't know, so far, does anybody have any question? I haven't started the actual practical work, but if anybody has a question, you can ask. All right, if you don't have any question, so I'll show you some examples of the plots using ggplot2. So this is the syntax. So the syntax, as I said, is the grammar. The syntax is the grammar. Excuse me, someone is texting me. Okay, so this is the syntax for the ggplot. So this is how you make a graph. So remember I told you that it follows a layered approach. The first thing you specify is the ggplot function. So this ggplot function comes from the so this is the package. The package name is ggplot2. And the function I use to do the plot is called ggplot. So the main function to initiate the plot canvas. So you specify your data. That is the data set that contains the variables I want to plot. And the next thing is you specify the mapping. Now the mapping is the aesthetics, like the X and then the Y axis, the values that you want to represent on the X and then the Y axis. But you can also map the values to a color or a shape. So apart from mapping the variables to the X and Y axis, you can also map variables to colors and then shapes, all inside this AES. So this is the first layer. This is the plot canvas. So I have my data and then I have my X and Y axis. The next is the type of plot that you want. Now in ggplot, all the plots or the type of plot starts with a geom, right? It starts with a geom. It is called geometry. So if I want, this geom point means scatter plot. So I want the plot to be points. So it is a scatter plot. So there are other geoms. There are box plots, there are histograms, there are line plots, a whole lot of plots. So it depends on the type of plot that you want. Then you specify this. And then the rest are optional. But to make the plot more appealing, you can add these other optional layers. So these two, the first two layers are the most important. The other layers, they are optional. Okay, so you add a layer with the plus symbol. So once I have this first layer, if I want to add another layer, I do plus, then I bring the layer on the next line, then I do plus, then I bring the layer on the next line, like that. So I can add as many layers as I want. But these first two are the most important. The rest. So the labs is adding labels. So the labs is like labels. So you can add a title to the plot. You can change the x-axis. So default, the x-axis label uses the variable name. And then the y-axis label also uses the variable name. But you can change it using the labs. So you can specify a new x-axis label and then a new y-axis label. Changing the label doesn't mean you are changing the variables. The variables are the same. But then you see that x values, maybe the variable name doesn't look good. So you can change the name so that it looks good. So this is the syntax. So here is an example. So this is an example of a line plot using ggplot2. So a line plot of car brands versus PAG versus MPG, sorry, miles per gallon. Now this is a default data set that is found in R. So in R, there are also some data sets that are inbuilt that you can play around with. And this is a bar chart. So this is a bar chart, this is a bar plot for the same data set, the MT cars data set. And then this is a histogram. So this is a histogram from the same data set. So this is a box plot. So in a box plot, what a box plot does is it groups categories and then plots them so that you can see so this box here shows you the variability of the value. So it tells you how the values vary. So if the box is wide, it tells you that there's a lot of variation. But if the box is small like this, it means that the variation is really small. And then if you see a point, right, above or below these lines, so these lines are called whiskers, right? If you see a point above or below it, they are called outliers. So it means they are either too small or too high compared to the other values inside that data, right? Now these whiskers, this below here, this represents the minimum value or the minimum number. And then the top here represents the maximum number. And then a thick line here represents the median. right? And then here, the start of the box here is called the first quartile. So the median is the second quartile, or the middle or the center of the data. So this here is the center of the data, or the second quartile. And this line here is for the third quartile. It represents 75% of your data. The first quartile represents 25% of your data. So it means all the values here, 25% of the values here are below this number. And then 75% of the values are also below this number. And this is exactly the center of the data. So this here, this range, the box range, it is called interquartile range, or IQR. So the box plot tells you a whole lot about your data, right? Tells you a whole lot about your data. Okay, so this is a scatter plot. So this is a scatter plot. So you see that they are points. They are points. So I have miles per gallon, I have weight. And then you see that they are colored according to cylinders. So this is the legend. So the red here means that they have 4 cylinders. The green here means that they have 6 cylinders. And then the blue here means that they have 8 cylinders. So here you can see clearly that there's a pattern, right? There's a pattern. So you see that as the weight increases, the miles per gallon is also reducing. So there's a pattern. So the heavy cars, right? The heavy cars are also the cars with more cylinders. And it makes sense because if your engine is 4-cylinder and my engine is 8-cylinder, ideally my engine will be heavier than yours. So it means my car will be heavier than yours. So you see that the heavier cars have lower miles per gallon than the lighter cars. So you see the lighter cars also have small cylinders. Okay. So these are just some examples of the plots that I can do with GGB. These are just an example. There are a whole lot of plots that I can do, right? There are a whole lot of plots. Now, we have seen how to import the data. We have seen how to wrangle or manipulate our data. We have seen how to do plots. Once you see that here, I have seen that miles per gallon and weight, they are related, right? So now the plot is showing me that they are related. Now I want evidence. I want to prove that they are actually related. This is where the statistical test comes in. Now the plot is showing that they are related. So you can see clearly here that there's a pattern, right? But you see that in the raw data, you cannot see this pattern. If I hadn't done this plot, I wouldn't know that maybe the heaviest have lower miles per gallon, right? But now that I did the plot, I know that the heavier cars have lower miles per gallon. So I want to confirm it with a test, right? So there are different tests that you can do, right? So our has a comprehensive environment for performing various tests. So you can do a t-test. So the t-test, we have the student t-test. We have the correlation. So the correlation test, so here, the miles per gallon and the weight, I can test their correlation. So the correlation is like the relationship between this and this. So the t-test, this is a function to perform a t-test. This is a function to perform a correlation test. And the LM is for linear regression. So you can do linear regression, you can do a chi-square test, you can do a correlation test, you can do a t-test, you can do a logistic regression test. So I'm sure yesterday my colleague made mention of some of these tests. But for our analysis, we'll be doing only the t-test and then the chi-square test. But know that R can handle a lot of tests, a lot of statistical tests. So there are, as I said, there are a lot of packages that you can use to do all these things. But for these tests, these are built-in packages. But then there are also external packages that you can use to perform these same tests, right? But for what you will do, I think we will just use the inbuilt functions. So these are inbuilt. So to use these functions, you don't need to install any package, right? You don't need to install or load any library or load any package. You just use them straight away because they are inbuilt. So they are part of the R environment. So these functions are essential for hypothesis testing, correlation analysis, and linear regression. So the t-test, in order to do a t-test, you have to do a hypothesis testing. So the t-test, it has 3 types of hypothesis, right? There's a right tail test, a left tail, and then the 2-tail test. Those are all types of hypothesis, but we wouldn't go much into that. All you need to know is that the t-test is used to compare the means of 2 groups, right? So let's say I have the steady group that we are going to look at. The steady groups, they are 2, so we can use a t-test. If they are more than 2, we cannot use a t-test. If they are more than 2, we use something we call ANOVA. So ANOVA is called analysis of variance. So ANOVA tests the difference between means for 3 or more groups. But if the groups are only 2, then you can do a t-test. Okay. Now, before we start doing our analysis, we need to know the sample size, right? So as medical students, mostly you'll be dealing with a sample size, and then you need to have a reasonable sample size, right, to get proper results. And the sample size is related to the power. So the power, we call it statistical power. Now, the statistical power refers to the probability of correctly detecting a true effect. That is not committing a type 2 error. So the type 2 error is represented by this beta. So the type 2 error is also a probability. So the type 2 error is a false negative. So a false negative is like the actual thing is true, but then the actual thing is false, but then after your analysis you get true. So that is a false negative, right? If you want to prevent this type of error, you need to specify a reasonable power. So mostly the acceptable power that we mostly use is 80%, right? And then the power is also related to the sample size. Ideally, we would want 100% power, but that is not feasible because 100% power means you need about more than 1 million people, right? So where are you going to get that 1 million sample? It is not feasible, right? So you can also go as high as 90%. So the 90%, so the more like the higher you go for the power, the higher the sample size, right? That is why it is mostly accepted that you use 80% because 80% gives you a reasonable sample size. So the sample size for a 90% power is greater than the sample size for 80% power. So mostly we consider all these things before we choose the power that we want, right? Now, you don't need to remember all these equations. So there are a lot of equations concerning sample size calculations and all that. R can do that for you, right? You don't need to worry about formulas and all that. That is why you have R. So you just call a function, you give it some arguments, and then it will calculate the sample size for you, right? So if we choose an 80% power, it means that if there's really an effect of the probiotic that you have, so let's say the study that we are doing, right? We are checking vitamin D probiotics. So we've given these supplements to a number of patients. So we divided those patients into 2 groups, and then we gave one group the supplements, and then we didn't give the other group. So we want to check if there's really an effect. So if there's really an effect, we want to have an 80% chance of detecting that effect. So this is a reasonable chance. right? So if you have a 50% chance or a 60% chance, then it means there might be an effect, but you might fail to detect it. That is where the type 2 error occurs. So if you have smaller sample size, maybe after your analysis, you say that, oh, maybe the analysis will give you a p-value that is not significant, but that might not be the case. It could just be that your sample size is small. That is why you are getting that p-value. But if you had increased the sample size, then there might be a chance of detecting some effect. So that is what power is. Okay, so as I was saying, why not 100% power? So 100% power means detecting true effects every time. So this is not reasonable, or this is not practical, because you cannot always, you cannot have a 100% chance of detecting an effect, because there are other variables affecting your sample, right? So there are other factors, there are various factors that can affect. So even if you choose 100% power, which is not reasonable because you cannot get the sample size to do that. 100% power means a very large sample size. So it is sometimes considered infinite sample size because it is very large and you cannot get it. So it is 80% is a conventional and practical, which gives a reasonable sample size. Okay, so this is the formula for calculating the sample size. So as I said, you don't need to remember this, right? You don't need to remember this. So N here is the size per group. So I told you that the t-test is for 2 groups. So when you calculate the sample size, the N that you get, it is for 1 group. So let's say you do and you get, let's say, 50. It means you need 100 samples. So it means your sample size will be 100 because the 50 is for 1 group. Okay. So these are the terms explained here. I wouldn't. Okay, so the sample size for a t-test depend on the significance level. So the significance level here, this is the alpha. Where is it? Yes, this is the alpha. So mostly the significance level is pegged at 0.05. And then the power, which is usually 80%, and then the coherence D. Now, the coherence D, you see that here we have effect size. This delta here. This symbol is called delta. It is called effect size, right? Now, depending on the type of test that you want, the type of test will determine the type of effect size that you are using, right? The type of test will determine the effect size. So if it's a t-test, we mostly use the coherence D. So the coherence D is a specific measure of effect size, mostly common for the context of a 2-sample t-test. So this is the formula. So as I said, you don't need to know this. Just all you need to know is like the theory behind what you are doing, right? If you know the theory behind what you are doing, and then you are typing the code, and then you are getting output, then you know that, oh, okay, this makes sense, this doesn't make sense. I hope that is clear. So here, this is how you can determine the sample size for a t-test, right? So R provides an easy way to do this. So there's a package called PWR, right? Inside this package, there's a function called pwr.t.test. Now, what you need to input here is the coherence D, the power. So this power and the significant level, and then the coherence D, you decide it. Now, for a t-test, so the coherence D, the range is, I think, between 0.2, 0.5, and then 1, right? So the coherence D is like the effect size. Now, mostly we want a medium effect size. So the 0.5 is like a medium effect size. And then if you want a small effect size, which is a 0.2, you can also use 0.2. But using a small effect size means that you might risk missing the chance of detecting any effect, right? That's why we use a medium effect size. So all these items, D, power, and then significance level, these ones, you decide them yourself. So instead of 80, you can use 90. but these are standard values, right? They are conventional values that are accepted internationally or statistically. Even a significant level, you can decide to choose 0.01, but mostly it is 0.05. Okay, and then the type, so because it is a t-test and we want a two-sample t-test, we can specify the two-sample. So this and this, they are default. You don't need to specify them. The alternative is the type of hypothesis that you want. So as I told, we have the right-tailed t-test, the left-tailed, and then we have the two-tailed. So this two-sided means we want the two-tailed t-test. Okay, so you see that here for the sample size for the t-test, there is Cohen's d. But there's also a different way of calculating the sample size for regression. So the regression is the LM and then the ANOVA. So ANOVA is when you have more than two groups, right? So the effect size for the regression is this. And then the effect size for the ANOVA is this formula. So as I said, you don't need to put all this formula in your head. The only thing that you need to know is this function, pwr.f2.test. This is regression, and then pwr.anova.test. This is for ANOVA. So ANOVA is for more than two groups. T-test is for two groups. So this eta, so this symbol is called eta. So eta squared is a proportion of total variance explained by the group difference. And then this is R squared. So R squared is a proportion of variance explained by the model. All right, so just like that, for the regression, for the regression model, this function will not directly give you the sample size. It will give you the degrees of freedom. But then you can use the degrees of freedom to calculate the sample size. So this is the relationship between the sample size and the degrees of freedom, right? So this V here, this is the degrees of freedom. And this U, the U here represents the number of predictors. So the number of predictors is the number of variables that you are using to predict the response variable. So in a linear regression, we try to predict an outcome based on certain variables. So let's say a person is fat, right? You want to predict that fat outcome using maybe the person's age, the person's height, and then let's say the person's nationality. So those are called predictor variables. So if you have, depending on the number of predictor variables, you specify that. So let's say I have 3 predictor variables. So this F2 is the effect size. So the effect size to, there's a range. So I'll show you later on. So this 0.15 is the medium range effect size. And then the power. So the power, I leave it at 80%. And the significant level is still 0.05. So this will give me an output, which has V. So V here is the degrees of freedom. So once I know V and I know the number of predictors that I have, I add them and I add 1 and I get the sample size. So here, maybe you, after this, maybe you need to do some small calculation, but this is just normal addition. So this is better than using this formula and using this formula, right? Okay. And then the next one is the ANOVA. So the ANOVA to, instead of the U, it is K. So the K is the number of groups. So as I said, for what do you call it? For the regression, you specify the number of predictors, but for ANOVA, you specify the number of groups. And then the effect size also, 0.25 is a medium effect size for an ANOVA. So 0.5 is a medium effect size for a t-test. 0.15 is a medium effect size for a regression analysis, and then 0.25 is a medium effect size for ANOVA, right? So these are the effect sizes. So this one will also give you the sample size. So these are the a summary of what we just did. So here, the t-test use the effect size, the Cohen's d, and then the regression is the f squared, and then for ANOVA, it is the Cohen's f. So all these things, they are formulas, but I don't need to know them. So the typical values. So for a minimum effect size, you use 0.2. For a medium, use 0.5. That is the Cohen's d. And then the f squared. For a minimum, use 0.02. For a medium, use 0.15. And then for a high effect size, use 0.35. And then the ANOVA, which is the Cohen's f. These are the values. And these are the formulas for calculating the sample size based on the typical effect size, the power, and then the significance level. Okay. Then we'll move on to the t-test. We'll move on to the t-test. So the t-test here, the t-test, as I said, it is used to check whether there is a significant difference between the means of two groups. So let's say I have this group, I have this group. I want to check, maybe I calculate the weight of all these people, and I calculate the weight of all these people. And I want to check if there's a difference in their weight, right? So if I do my test and I get a p-value which is lower than the 0.05, then it means there's a significant difference. But if I do the test and then the p-value is, let's say, or the significance level. So the significance level is also called p-value. If the significance level is greater than the 0.05, then it means there is no difference, right? And there are 3 types of t-test. We have the 1 sample, the 2 sample, and the paired sample. So I'll not go into details into that. This is the function, right? This is the function. I think time is far spent, so I'll just brush through so that we can quickly go into the RStudio and then perform the actual analysis, right? So this is the function for performing a t-test. And then the correlation test. So this is a function. So this computes the relationship between 2 variables. Now, the fact that you are determining the relationship between 2 variables doesn't mean that one is the cause of the other, right? So let's say you go to the hospital, or let's say you gather a group of cancer patients, and then you just ask them questions. Do you smoke? They say yes. Do you smoke? They say no. And then you come down, you prepare your table, or you prepare the data, and then you do a correlation test. And then you see that the cancer patients, most of them replied yes, that they smoke. Because most of them replied yes, when you do the test, it will show a significant relationship. That doesn't mean that smoking causes cancer, right? All right, I'll share the slides with you, don't worry. So once, because that you are, because you've determined that the smoking, the people that said they smoke, they have cancer, it doesn't mean that smoking causes cancer. It only tells you that there is a relationship between smoking and cancer, right? So correlation does not imply causation. Correlation only shows relationship between 2 variables. So the correlation has a value range. So it's between -1 and 1. So if it is -1, it means as one increases, the other is decreasing. So as we saw in our plot for the MPG and then the weight, so you see that as the weight is increasing, then the MPG is also decreasing. So that is a negative correlation. But for a positive correlation, as one increases, the other also increases. So let's say for your analysis that you went to interview cancer patients and they said they smoke, and then you came to do your correlation test And then you saw that smoking and then cancer, they are correlated, because smoking and then is increasing and cancer is also increasing. That doesn't mean that smoking causes cancer. The only way that you can imply causation is when you do a controlled experiment. So the controlled experiment, you can gather people, right? And then actually let them smoke, and then you monitor them. But that is not ethical, right? You cannot just go and call people they use mice, right? Or rats. And then they apply, maybe they want to test a certain medicine, right? They want to test how efficient or if a certain medicine can cure a certain disease. So that one, if they do a controlled experiment and then they do their statistical analysis, then they can say with evidence or with proof that indeed this medicine is causing this disease or it is curing this disease. That one, it is correlation and causation because they have done a controlled experiment. But if you don't do any controlled experiments and then you just go and do interview, you cannot imply causation. You can only imply a relationship or an association. I hope that is clear. Okay, so here, this is a function to perform a correlation test. And then the LM function is for regression. So the regression establishes a relationship between a dependent variable and then one or more independent variable. So the dependent variable is like the variable that you are predicting. And then the independent variable is the variables that you are using to predict this. So these are predictors. So here, this demonstration, this response variable is money. Now, you want to know if time, education, and experience can be used to predict if a person is rich or not, right? So time, education, and then experience. If I combine all these things, can it adequately predict that a person is rich or not? So if a person has a lot of time, if the person has some level of education and then some level of experience, does that mean a person is rich? Right? So all these things come together. Now, this one also, it doesn't mean causation. So it doesn't mean that if you are educated, if you have experience, so if you do this analysis and then you get a significant value, which means that this can predict this. It doesn't mean that this causes you to become rich. So as I said, you can only imply causation in a controlled experiment. So if you haven't done any controlled experiments, but you have just done a survey, right? So here you interview people, and then the analysis is giving you a significant result, you cannot imply causation. All right. So this is the function for the regression. So the LM and then the formula and then the data. So this is how the formula looks like. So the formula, the first item is the response variable. So here we are predicting money or richness. And then you bring this symbol here. It is called a wavy sign or tilde. And then you can bring your predictor. So predictor 1 plus predictor 2, blah, blah, blah. If you have 100 predictors, you do plus, plus, plus like that. And then you specify the data, right? You specify the data. So the data ideally must contain this variable and these two variables. All right. So I'm not going to do this reproducible reporting. So let's go straight to our house studio. So as I said, we will not use. Can you see my screen? I don't think. Can you see my screen?
Yes, we can see your screen, Sir George.
You see the house view or the PowerPoint slide?
We see the PowerPoint slide.
Okay, then let me switch. You see the R Studio now?
Yeah, we can see the R Studio interface.
Okay. All right. So I just made this. So this is how you can do the reproducible reports, right? So you see that this, you see I've combined text, code, tables, and then you see graphs. So I'll just show you how it works. I'll click on this render, and then it will do some rendering, some background jobs. To do some background jobs, and then it will give me an output. Here I want an HTML output. So I can view it in my browser, right? I can view it in my browser. So this output, I'm just showing you how the reproducible report looks like before we start the actual analysis. All right, so so far what we've done in the presentation, if you have a question, you can ask. So I'm sure you all have the data that we are, you all have this data, right? This article and then the data that we are using. So vitamin D probiotics fortification, improve vitamin D and total antioxidant capacity. So we are only looking at the vitamin D. We are not looking at the antioxidants. For this analysis, so we are looking at the vitamin D. So capacity levels among pregnant women, a single blinded randomized control trial, right? So let's see. Anybody has a question so far? Yeah, I think the file is almost ready. So no one has a question. All right, so it means you all understand what I just showed you. Okay, so I want someone to tell me this. What is the difference between okay, so this is how the file looks like. So let me just view it in my browser. So that's okay. So you see this vitamin D probiotic study analysis. So these are metadata, right? So you see how the report looks like, right? You see how the report looks like. So I have this. So I did my t-test. So these are the codes. So you see it combined codes with text and then tables, right? And then the visualizations, so you see, so this is the code for this. And then this is also the code for this, right? And then this is the code for this. So you see how nice it looks, right? So this is also another graph. And then this is also another graph. So this is the code for this, right? So you see how nice it looks. So so once you have this file, right? Once I have this file, I can share it with anyone. So this is an HTML file. If I want a PDF file, I can create a PDF file and then I can share it with anyone that I want. Okay, so I was asking a question. I want to know if what is the difference between a character variable and then a factor in R? So I showed you what a character variable is and then a factor variable. So I want someone to just tell me what a character and then a factor is in R. If you were actually listening and if indeed you understood what we just did. So anyone, or you want me to mention names? Anyone to help us? Wow. So is it that you don't understand or you just don't want to talk? Hello. Okay. I think I have to. Let's see. Brian Echampong. Can you kindly tell me what
This is
a,
interesting.
a character
Hello,
variable? And then, yeah,
can you
hello.
hear me?
Yes, I can hear you.
Wow, this is interesting. Okay, so um, a
Just
character variable
yeah.
basically is more or less like what in other programming language we call refer to as strings. Like say
Okay.
you want to create a variable to hold someone's name, like first name, then just create a variable like first name and then you store the name like Brian. So that's basically
Okay.
a character variable.
All right.
Then the factor is probably similar to like a list. So in this case, like categorical data. So from your example, you wanted to hold create a character of the student levels in a university.
Mm-hmm.
So level 100 to say level 400. You can
Mm-hmm.
put that in a category. That's basically the factor variable. And we use the C. Yeah, if I'm correct, we use the C
Mm-hmm.
as part of the variable. Yeah.
All right. All right. Yeah. Thank you very much. You've done so well. Okay. So let me clarify with it. So a list, right, in R is different from a list in Python, right? So in R, we mostly call it a vector, but in Python, maybe you might call it a list. So the factor variable that I created, it was a vector. It was actually a vector, right? But you have done well. It means you are following everything. So thank you. Thank you very much. All right. So I have my data here. Let me open the data. So I'll show you how to import a data, right? Where is the data? I'll show you how to import a data. Vitamin D fortified data set. Yes, this is it. Oh, what's happening? Let me open this. So this is the data set, vitamin D fortified data set. This is an Excel file. Right, this is an Excel file. So I'm opening the Excel file so that we see what it contains. All right, this is it. So this is the Excel file. Now remember I told you that these headers, right? These headers, PID, study group, age group, educational level, numbers, these are called variables. So all the headers, they are variables. All the headers are variables. And I told you that you can create a variable in R like this. So let's say age. So the variable is called age. And then I use this symbol. So there's a shortcut key for that. It is alt plus hyphen. So alt plus hyphen will give you this symbol. Or I can just use equal sign, right? So age, I want to create a variable called age, but I don't want a single age. So I'm creating a list or a collection of ages. So here I'm creating, let's say 10 ages. So let's say 25, 30, 31, 22, 26, 28. So I have 1, 2, 3, 4, 5. Okay, I think 6 is okay. So you see how you create a variable. Now, when I press enter, nothing happens. If I call age, you see that the numbers are showing. So now this is how you create a variable. I've created a variable. If I want to write a comment, this is my first R code. You see, nothing happened. It is a comment, so it will not be run as a code. Now, I don't know if anybody is following along, but then when you open your R, right? When you open your R, by default, this console here, it is down here. And then this environment is up here, right? But I have changed mine. And then the appearance doesn't look like this. So the appearance looks like this. So let me use the default appearance so that you can all. So the appearance, I think it is TextMate. Okay, so this is the default appearance, right? So this is how it appears. And then this console is found down here. This console is found down here. Now, when you open R, you not see the script pane. You only see the console. So the console will appear down here like this. And then the environment will be somewhere up here. Now, if you want to see the script file, all you need to do is click on this plus, new file, and then click on R scripts. Then it will open an empty page for you here. So it's like a blank page, right? So you can type any code. So I want to create my age here. So age, let me copy and paste. I don't want to be typing plenty like that. So I have my age here. If I want to run this code, I leave the cursor either at the beginning or at the end, and then I press run. So once I run a code in a cursor, sorry, in a script, it will also run in the console. And then you see that it is here. It is stored in the environment. So you see that age is here, right? Age. And then the value. So you see that it is numeric and there are 6 items. So you see 1:6. So 1:6 means there are 1 to 6 items. Okay. Now I have my age. Let's say I want to create, let's say another variable called name. So name equals, I bring C because I am creating a vector. So anytime you are creating a vector, you start with C. So name, I'll start with Grace. I put it in quotation marks because I am creating a character variable. And then I start, the next is Ernest. And then, so I want to also create 6 values. So Ernest, Grace, Prince, Vivian, and then Steph. All right, so I have 1, 2, 3, 4, 5, 6. So I have 6 items, so I run this one too. Now I have name, another variable called name. So when I do name, so let me type this in the console. When I type name, you see that I have these names appearing. Now, these 2 variables, right? I can create a data frame out of these 2 variables. So you see that age and then study group. The names are 5, are you sure? 1, 2, 3, 4, 5. Oh, sorry, the names are 5. Yeah, 1 to 5. Okay, let me add another name. So it should be a girl. So Beatrice. Okay. So I've added another name, so I'll run it again. So now you see that now the names, they are 6. Okay, thank you for that. All right, so I have age, I have name. As I said, I can use this, looking at this. So ideally, these PID, study group, age group, they are just like this. They are individually, they are vectors, right? individually, they are vectors. So if I combine them, so I can combine them using data.frame, right? So data.frame, I'll just call age and then name. Because I already have those vectors, when I run this, you see that it has created this. So this is just like my Excel data here. So you see that it's just like my Excel data. So imagine that you have all these values. So you need to create PID. So if I want to create it in R, then it means I have to create a variable called PID. And then I'll input all these values here. And then I'll create study group. I input all these values. I'll create age. All this you'll just be wasting your own time, right? You'll be typing plenty, and then you might even make a mistake. That is why we say that R doesn't provide this interface, right? Here, if you make a mistake, you see. But when you are typing and you make a mistake, you don't see. So ideally, you prepare your table in Excel and then you import it into R. As simple as that, right? As simple as that. So let me put the data. So this data.frame, I can give it a name. So I'll call it my data, right? Equals to data.frame. So I'll do age, comma, name. So when I run this, so I can also press Control Enter and then it will run it. So you see that it has created my data here. So when I click on it, you see that I have age, name. So I can view the data. When I click this, it will open the data just like in Excel for me, right? So you see that it is opening it here, just like in Excel for me. All right, so this is just demonstration. So I'll show you how to import the data using the read R and then the read Excel package. So I already have the packages. So all I need to do is I'll just type library read Excel, right? Read Excel. Now, if I run and I don't get any error, it means the package has been loaded. And then the function that I need is called read underscore Excel. Right? This is the function that I need. But before we do that, let's check let's check the arguments. So there's a function called args. The argument. So the items that I need to specify in read Excel. So read Excel, I need the path. So the path is the location of the file, right? The path is the location of the file. And then I need the sheet. So if I have more than one sheet, so you see that I have two sheets. I have clean coded and I have sheet one. So if I want the clean coded, I should specify this. If I want this, I can specify this. But by default, it will give me the first sheet. So the sheet, the range, column names, blah, blah, blah. Most of these arguments, they are all optional. The only one which is not optional is the path. So the path is not optional. You need to specify it. Otherwise, the function will return an error. But the rest, they are all optional. Okay. So I know that all these are optional. I don't need to call them when I'm using the function. I only need a path. So what I'll do is before that, you see that when I click on the files, it is showing me the folder where I am working in, right? So here, and then you can even see the folder here at the top of your console. So I am in the data analysis clinic folder, right? So this folder, data analysis clinic folder, and then there's another folder inside called data. So this is where the data is. But if I want to check if actually I'm in that folder, I can do this get WD, right? So if I do get WD, you see that, okay, yes, I am inside the data analysis clinic folder. So all that I need to do now is, once I know that I'm in this folder, and then the file is inside this folder, inside a data folder, inside this folder, what I'll do is, I'll do read Excel. I put it in quotation marks, right? The path. I put it, you see that even the printed part is in quotation marks. So the quotation marks, it can either be double or single. They all work. So I want this vitamin D fortified data set.xlsx. You need to type the name exactly as it is. So I'll just let's see. I'll do like renaming it. And I'll just copy the name. So Control V. I need to add the dots XLSX, right? I need to add the extension. So this is the extension XLSX. If I don't add the extension, it will not read it. Now, if I run this, it will tell me that I cannot find the file. Why? Because inside this folder, inside the data analysis, there is no file called this. So let's run this and see. See that error, path does not exist. So it is telling me that this file, it cannot find it inside this location. So what do? I know that I am inside this location, and I know that this file is inside this data folder. So what I'll do is I'll just type data here, right? The folder name is called data, and I'll bring a /, right? So here I'm telling it to look inside the data folder. It will find this file. So now when I run this, you see that now it has found the file. So it is giving me this, right? It is giving me this. So this is the data. So you see that this is the data, the same in Excel, right? This Excel data, it is here. It is showing me this. Now, if you just use the function and then the path, once the data is printed like this, that is all. It means you have imported the data, but it is, how do you call it? It is not stored in memory. It just showed you the data and it is gone. If you want this data, if I want this data, then I have to run this function again. I don't want to do that. So the best thing is to store this data in a variable, right? So I want to store it as vitamin D data. And then I'll run the function again. So if I run this function again, now this is being stored inside this variable. So when I run this, nothing will happen. It means the data is stored inside that. So when I call vitamin D data, when I run it, you see that now the data is stored. So anytime I want the data, I don't have to run this function again. I just have to call vitamin D data. Right, so vitamin D data, it is also here in environment. So I can click on it, it will view it like in Excel. So here you see that you can view it just like in the Excel worksheets. Right, so I see this. Now you can see that I have NA. So where there is NA, it means that, so look at this, ND dies. All of them is NA, right? And then there's another variable called end. This is also NA. So all these things, the NAs, let's look at what it means in the Excel sheet. So it means, you see that there's no value here. So if there's no value in R, it is recorded as NA. So you see N, so you see N line here, there is no value here. So they are called missing values. So in R, missing values are represented by NA. Right, they are represented by NA. Okay, so once I have my data, the next thing is to, as I said, to do some manipulations and then clean it, right? Now I have seen that the data contains this. Okay, so I realized that in the data we had 2 sheets. So let's see if we can also read in the second sheet, right? But we only need 1 data set. It is the same, just that one has been coded. So instead of So the coding, you see that instead of the steady group being vitamin D fortified and then non-fortified, we have 1 and 2. So that is what the coding means. So I'll use the same function, read Excel. So when I click this and I press tab, read Excel, right? When I press tab, you see that it has opened some items for me. So it has basically opened all the files in my current directory. And I know that the file is located inside data. So I click on data. Why is it? It just opened the first file, sorry. So let me do it again. All right, so data. So now I am inside the data folder, so I can press tab again. And then I am looking for which one? Vitamin D fortified dataset.xlx. So I'm looking for this. Okay, now I don't want the first sheet, I want the second sheet. So I'll specify sheet equals 2, right? I can use the name of the sheet, right? The name of the sheet is cleaned coded. I can use this name, but let me use the 2 because it is the second sheet and see what happens. So you see that when I use the 2, it has read in the second data. So you see, look at this. The first one, I have vitamin D fortified. Here I have 1. So you see that I can read in the first sheet or the second sheet. I can equally use the name. So instead of 2, I'll use, I think it was cleaned coded, right? Let me check. Because if you make any spelling mistake, it will not come. So clean coded, you see that it also works. So you can either use a number or the name of the sheet. All right. Okay, so we don't need this data. We only need this data because ideally they are the same. It's just the way they are coded that's the difference. All right. So as I said, when we check our data, right? When we check our data, where is it? Vitamin D data. This is the vitamin D data. We see that this ND diet lifestyle and this end, we don't need it. And then study group, ideally, we want to categorize this, right? Study group. When I check this, it is just a character. But since our main aim, right, this study group is what we are interested in, I want to categorize it. So what I'll do is I'll use the dplyr functions, right? So as I said, the dplyr, if I want to use it, I'll call library dplyr. So once I call it, it means the function is ready for me, or the package is ready for me to use. So I can use any function inside dplyr. Now, there's another thing that you need to know. Let's say I want to do select, right? Select. Let's say I want to select study group. Sorry. Select the data is vitamin D data. And then I want to select study group. I think it's capital S. Study group. And then let's say, let me see, baseline vitamin D. Okay, and I want to baseline vitamin D, right? Baseline vitamin D. Oh, okay. You see, this is a spelling mistake. Look at how the baseline vitamin D. So the vitamin D is all caps, but I am using small letters. So it is vitamin D. So you see that I have study group and then baseline vitamin D. So I have selected these 2 variables from this study group. Now, there's a way that you can type it to make it look smooth. So if I check the arguments that I need the data, and then I need the variables that I want to select, right? So I can do this. I can do vitamin D data, and then I use this symbol. This symbol is called a pipe, right? So the pipe, it changes the function on the left side into the right side. So what this is basically doing is, if I do select, and then I specify steady group, comma, and then vitamin D status, sorry, baseline vitamin D, right? So what this is basically, it is doing the same thing as this, but the pipe is helping me make it look smooth. So I can add another pipe like this. So here you see that what this is doing is, it's this vitamin D data is being given as the input for this select. So ideally, the vitamin D is supposed to be in the select, but the pipe is directly pushing it inside. So the output, which is the vitamin D data here, it is being given as the first input of this. So if I do this, right, and I run it, it will still give me the same thing. Now I can add another pipe. Now this is the output. Look at this clearly. This is the output. I can add another pipe, Control-Shift-M, and I'll do group by, right? Group by, and then I'll select steady group, and then I'll add another pipe. I'll do summarize. So summarize, this is the only information that I have. So I'll do average baseline. This is equal to, so I want to calculate the average baseline vitamin D for each group, right? Average baseline vitamin D for each group. So I use the mean function. So baseline vitamin D. I don't know why there's a lot of brackets. So you see that when I run it, now I have non-vitamin D fortified and then vitamin D fortified. So the average is, for the non, it is 12.6, and then for the vitamin D fortified, the average is 14. This is baseline. So baseline is before they were taking the probiotics. So before that, even before that, the fortified group had a higher vitamin D level than the non-fortified group, right? You can see this from the mean. This is the baseline. Okay, now let me explain this code. What this code is doing is that it takes the output from here. So the output from here is the whole data set, gives it as the first input here, and then it will run this. Then this output, the output of select, this is the output. It will use it as the input for this, the first input, the first argument. So group by, ideally, it requires a data. So this data is what it will use. And then the summarize. So the summarize is like aggregating the data. So it summarizes the data based on a certain grouping. So this is the grouping, the steady group, the fortified, and then the non-fortified. So what this is basically doing is, it will calculate the mean for each group. So for the fortified group, it will check the values for the fortified group and then calculate the mean. Then it will come and check the values inside the non-fortified group and then calculate the mean. So this is the name that I give it. So ideally, it is going to create another variable, right? So I give it a name called average baseline. So average baseline is a variable that I created to store this value. So I have this. So this is how the pipe works, right? So I'm just showing you this because I'm going to use the pipe to remove this end variable, right? And then this ND diet lifestyle variable, right? And then I will reassign it back to the same data set. So let's see. The data is vitamin D, right? Vitamin D data. All right. So I'll call the same vitamin D data. Please, if you have any questions, you can ask. Vitamin D data. And then I'll do my pipe. So I'll do select. So the select can be used to select how do you call it? Data sets, and it can also be used to delete. Sorry, select variables, and can also be used to delete variables. So if you want to remove a variable, you do only what you need to do is minus. So I need nd diet this, and then there's another one called end. Yes, so end. Yeah. So let me bring the minus to. So when I do this, it will remove the two variables. So let me first not assign it so that I see the output. Because if I assign it, you not see the output. So I'll view so that you see how it looks. Right? So this is the output. So you see that now the end is not there, and then the ND, they are also not there. So I have removed those two variables. Right. All right. So I'm going to chain all this together. I'm going to chain all this together. So vitamin D data. So I have select. I'll do select. So I'll first assign it. I'll bring my vitamin D data. So I'll do select. And then the files that the variables that I don't need, nd diet lifestyle, and then end. Right. So when I do this, it means it is removed. And then it is reassigned back to this, the same name, because I don't want to change the name. And then I said I also want to change the steady group into a factor. So that I use a function called mutate. So the same code, the same process, sorry. Vitamin D data, and I'll do mutate. So I can chain all of them together, but then I want to do it step by step so that you get. So mutate is used to add a variable or modify an existing variable. So here I am modifying an existing variable, which is the steady group. So steady group equals factor. So as simple as that, factor steady group. Factor steady group. Right. So it has changed it to a factor. Now, if I want to check if this is true, I'll do this vitamin D. So I can view it. So you see that this data, okay, it doesn't show here, but let me just do str. Now, if I do str, you see that str is showing me the dimension of my data and then the data types. So PID is a character, steady group. You see now I have changed it to a vector, sorry, a factor with two levels. So the levels are the categories. So I have vitamin D fortified and then non-vitamin D fortified. So the two here means that there are two categories. So the age is a number, age group is a character. So you see how the data looks like with this str function, right? Okay, I don't know. I think, let me just type Okay, I have this file. So I'll share the markdown file with you, right? So that you play around with it. So this is just for demonstration. So let me just quickly. Okay, let me just quickly do this. All right. So now let's say we have cleaned our data, right? We have done some modifications, and then we want to go on to do some summary statistics. So with the summary statistics, we can use the DPLYR, but there's another package which makes it very simple. There's another package which makes it very simple, which is the GT summary. So there's a package, so I have to load its library, GT summary, right? Now, this makes it very simple, especially if you want to do a professional work, right? This package makes it very simple to create summary statistics. Now, here, let's say I want to check. So when I did the STR, let me do the STR again. STR vitamin D. So the STR, I want all the numeric variables. So let's say age, I want to do all the numeric variables, a summary statistic of all the numeric variables. So let's see. I'll vitamin D data, then I'll do select. So I'll do across where is dot numeric. So let's see if okay, so I cannot use the across in select. Hey, where? Okay, so then I thought I had a shortcut to do this. Okay, so these are the numeric variables. All right. So vitamin D. So I want to select where the variables are numeric, right? So is dot numeric. So this will select all the numeric variables for me, like this. Now I want to do a summary. So I use TBL summary. So I want to do a summary of this TBL summary. Let's see how it looks. So I want a summary statistic of all the numeric variables. So it is doing some background calculations. Yeah. So you see how it looks like. So this is how it looks like. Let me enlarge it. So you see how it looks like. So all the numeric variables. So the age, so the total N, which is the total, my sample size is 26. So the age, this, the number of previous pregnancies, the household size. So unknown means missing. So number of children, so diet score, baseline, end line, and then known. So here the default is, let's see, it is median, the Q1 and Q3. So Q1 is the first quartile, and then the third quartile, and then the N, and the percentage is, the N percentage is the number, and then the frequency, and then the percentage, right? So the frequency and then the percentage. So you see that it has created a nice summary for me. So this is very professional. You can use this inside a document, right? But this is an HTML format. This is an HTML format. if I want to use it in a Word document, there's another package called Flex Table. I don't know if it's already loaded. So library Flex Table. Okay. So this same code, I'll change it to as Flex Table. So it's already a table, but because I want to export it to a Word document, I'm changing it to Flex Table. And then let's say I'll do save as docs. So save as docs, I'll specify the name I want to save it. So just summary.docs. Right. If I do this, it is still running because I didn't save the previous output. It is still running the whole thing again. Right. I didn't save it inside any variable. So anytime I want to do it, I have to run it again. But if I just saved it in a variable, this thing would have been saved. And then, oh, I just need to specify the path. Just need to specify the path, that's all. So because I didn't save it in a variable, I have to run the whole thing again, and it takes some time to do that, but it wouldn't take long. So here, what I am doing is this summary table that I created, I am changing it to a flex table. So the flex table is another type of table, right? It's another type of table, but then you see it is done. So if I check my files, I'll see that there is a new Word document called summary.docs. So I can open it, and then I'll see that this table is inside. So you see that I have my table nicely here, right? In a Word document. So here you can edit it as you see fit, right? You can edit it as you see fit. So this is just to show you that you can export it into a Word document. All right. So now let's say we've done our summary statistics. Then we want to go into the actual inferential statistics, right? Or we can, let's say, do some scatter plots. So before we start, we do some, so library ggplot. So we want to do some scatter plots. So I want to check this, the baseline. Where is it? I want to check the baseline vitamin D and then the end line vitamin D. So baseline and then the end line. Baseline, end line. So these are all numeric variables. So a scatter plot ideally requires numeric or continuous variables. So if they are not numbers, you cannot use a scatter plot to, let's say, visualize it. You can use either a bar chart or a box plot. So ggplot. So data equals, the data is vitamin D. So this is the data that I want. So I'll do AES. X is, so let's say I want the baseline to be the X. So baseline, and then I want Y to be the end line. So I am done with the first line or the first layer. So the second layer is a geom point. So geom point, okay. When I finish this, I'll add another mapping, right? So let's see how it looks. So 131 rows containing missing values. So you see that there were missing values inside the end line, right? Inside the end line, there are missing values, so they have been removed. So this is how the plot looks like. So let me zoom it, right? So this is very basic, right? This is very basic. vitamin D, end line, and then the baseline. So this is very basic. So this is how the scatter plot looks like. Now I'm going to add some other layers to make it look more beautiful, right? So the same code, I'll add AES, another mapping here, and then I'll do this one, I'll assign color rather, because I already assigned X and Y. So the color, I want the color to be steady group. So I want it to be colored according to steady group. So this is the steady group. I want it to be colored according to steady group. And then I'll add labs. So I'll add labels. So I'll change this label to, so X equals, this is the X baseline. Baseline, so it's a character, so I put it in quotation marks. And then Y will be end line. So I'll add a title. So title equals vitamin D, let me do status, right? And then to make it appear nicely, I'll add a theme. So I'll do theme classic. So let's run this and see what happens. So now you see how it looks. So let me zoom it. So now I see that now it looks more presentable. So now I have end line and then baseline. And then it has colored according to steady group. So the non-vitamin D fortified are the red ones. And then the vitamin D fortified are the, what do you call it? The blue ones. So it has colored. And then once I added, you see that once I added the color mapping, it will automatically add a legend, right? So it makes it look nicer. And then the theme classic is this appearance, right? The x-axis and the y-axis line. So I can change the theme. There are several themes, so I can use theme minimal. It will also change the appearance, right? To change the appearance. So you see that this is also appearing differently. Right? You see, this is also nice, but the x-axis and then the y-axis lines are not as thick as the theme classic, but then you have background width. Okay, so this is also appearing nice. So let's say you have a plot like this, and then you want to export it to a Word document. All you need to do is click on the export, save as image, right? So it is just a picture. So you determine the size that you want. So you can crop it as you see fit, and then click on save. Right, click on save, or you can just right click and copy image, and then you come to your Word document. You come to your Word document here. So this is my work. So I'll just paste it here. So I want the image. So you see that when I paste it here, so yes, I have my graph nicely pasted in my Word document. So I can add a boundary to it. So format, can add picture border. So yes, I can add a border like this. And then I have included my plots nicely in my document. Right, so nicely like this. So this is a scatter plot. You see how nice it is? All right. So let's move straight ahead to our inferential statistics. So what we want to know is, because we tested 2 different groups and then we followed them for 6 months, we want to know whether there's a significant change. We want to know whether there is a significant change in the fortified group and then the non-fortified group. Because ideally, when we looked at the averages, the fortified group had even a larger vitamin D than the non-fortified group, even for the baseline. So after the probiotics, after they've taken the probiotics, which is the end line for 6 months, we want to check whether there is indeed significant difference or not, right? So we test the study group against the end line, right? So we can test the study group against the baseline. So the baseline, when we calculated the mean, we saw that one was higher than the other. But let's see if it is a significant difference, right? So I'll do t.test. T.test. This is the function for doing a t-test. And then I'll specify the data that I want to compare the groups with. So the data is the baseline. So it is baseline. So you need to be careful with the spellings, because if you make a mistake in the spelling, it will give you an error. So baseline vitamin D, baseline, the vitamin D is capital. Then I specify it in the form of a formula, right? And then I am checking it against the study group. So study group. Then I'll specify my data. And then I'll specify my data. So data equals, data will be vitamin D data. All right. So t.test, I specify this as a formula. Because these variables are inside the data, I specify them as a formula, right? So when I run this, it will give me the output. So I have a well-2 sample t-test, baseline vitamin D. So the t statistic, the df, this is the degrees of freedom, the p-value. Now, this is what we are interested in, the p-value, which is 0.2. And then the alternative hypothesis. So I told you that before doing a test, you need to specify a hypothesis. So for a t-test, the hypothesis is that there is no difference between the groups. So the alternative hypothesis is that there is a difference between the groups. Now, if you get a p-value where the value is less than 0.05, then it means you reject the null hypothesis, right? But here, we see that the p-value is not less than 0. So we cannot reject the null hypothesis. So it means that there is no difference, although the mean is 12.6, and then the mean is 14, which is slightly higher than this. The test is telling us that although this is bigger than this, the difference is not significant, right? So this is what the test is telling us. The difference is not significant. So it means there is no difference between the study group and then the fortified and then the non-fortified group, right? So this is the non-fortified, this is the fortified. There is no difference because the p-value is greater than 0.05. This is for the baseline. So the baseline is before they were given the probiotics. Now let's do the same for the end line, right? So I have T, so end line is this. Now, if you type any code in your console, you can just press the up key, right? The up or down key. It will take you back to that code. So I just press the up key so that the same code comes, and I just change this to end line, right? Because previously I just checked the baseline and now I'm checking the end line. So let's run this and see the output. Okay, so this is the output. So the mean for the baseline is, so the mean for the non-vitamin D fortified is 11.9, and then the mean for the fortified is 16. And then this is less than 0.05. So here we see a significant difference, right? So here we see a significant difference. See a significant difference. All right, so this is how you can do a test, right? The t-test when you have a data set. So if you have the variables inside the data set, you just specify the variables. So you specify the variable with the numeric or the continuous data first, and then you bring a wavy sign, and then you specify the variable with the groups, because you are comparing these groups for these things. So now we see this. So we can do this plot. You can do these plots. I think we spent a lot of time here. We spent a lot of time. So you can do these plots. So I'll share this file with you and then you look at them. So, but let me just explain what this plot is. So this is a box plot combined with a scatter plot, right? And this is the p-value. So this is what we just did. This is what we just did. So this is the non-fortified and then the fortified for the end line, right? And the p-value is significant. So it means the differences in these two groups, they are significant. So it means our probiotic administration actually worked. So it means that the probiotics that we administered increased their vitamin D. So because if you can see, this is slightly higher than this. Although it was not too great because the p-value is not too far from 0.05, right? It's 0.03. Although the difference is not too great, but still it is significant, right? It is significant. Okay, so we can do this plot using the GG plot. So let me just do this plot for you, right? But to add the p-value, you need another package called JJPUBR, but we don't look at that. I'll just show you how to do this very quickly using ggplot. So ggplot, I want to wrap up everything so that if you have any question, so by, let's say, it's 5:45, wow. Okay, so let's say by 5:50, we should be done. So I'll just show only this plot. I'll just show only this plots and then we can wrap up. So ggplot, so the data is my vitamin D, and then the mapping, the AES, my X will be the steady group, right? The steady group. And then my Y will be the end line, end line vitamin D plus. So I want a box plot. So we use geom box plot. So the geom box plot, what I'll do is, you see this color here, I'll color according to the steady group. So AES, I'll do color. So this is color. So when you see the outline color being changed, it is color. But let me do fill so that I see the difference between. So fill equals steady group. So I'll use the steady group as the fill. Then I'll do plus. So I can add the scatter plot. So jump point. And then I'll change the theme to classic. Theme classic. So I won't change the labels and then the title. So let's see how this one looks. Okay, so you see how this one looks. So this one looks slightly different from this. So you see that these points, they are a bit sparse. But I see that these points, because, so you remember I told you that a scatter plot can only work for two continuous variables. But here I have a numeric variable and then a categorical variable. That is why it is like this. but I can do something so that it appears like this, right? It appears like this. So inside the jump point, I can specify an argument called position. And then I'll make it jitter, right? Position equals jitter. Now, when I run this, you see that the points will be a bit sparse. So let's do position jitter. You see that, right? You see that the points are a bit sparse now. So you see that the points are now spread out a bit. Instead of just this straight points like this, the points are spread out. But I can control the spread, right? I can control the spread if I do this position jitter, and then I'll do width equals, let's say, 0.1. Right, so this will control the spread. So let's see how this is. So you see that this is not too widely spread. So you see that the way this is widely spread, this is not too widely spread like that. Okay, so this is how you do a scatter plot. So I can also change, the, what do you call it? The point, I can change the size, jump point, right? I can change the size. Size equals, let's say, let me do 0.5. And then the box plots, I can make it transparent. I specify alpha. Alpha will make it transparent, 0.5. So let's see. So you see that the points have become smaller, right? And then the alpha, right? The alpha, you see that now the box plot, let me zoom it so that you see what I actually mean. So you see that now the box plot value. So the box plot, it contains its own points. So these points are outliers, right? Apart from the points from the scatter plot, the box plot contains its own points. These are outliers. Now I can control the outliers in the box plot. So inside the box plot, I'll do outlier dot shape, and then I'll do any. So any means missing or nothing. So let me increase the points to, let's say, 0.8 for the jump point. Let's see how this one looks. So you see that it has removed the outliers, right? So let me zoom it. So here you see that the points that were here are now gone. So the outliers from this are now gone. So this is how you can do your box plots. So I'll share this file with you, right? This file, the bar chart. So this is a QMD file. So I don't know if I can share it within the chat. So the people, those that are here, I want to share it within the file right now, because I don't know if some of you registered or not. So those that registered, you receive it through your emails, right? But for those of you that are here, let me just quickly put it in the chat so that you can download them. Okay, so if you have any question, so this file, you can only open it in our studio. Yes, so I've shared the file with you, so you can download it and then open it in your house studio and then play around with it. All right, so I'll bring everything to an end here. I think we've spent a lot of time. Because of the presentation slides. I couldn't take you through all the practical aspects, but I hope at least you've grabbed something, and then you can do a t-test, right? You can do a t-test and maybe do a simple scatter plot. At least I hope you can do that. So if you have any questions so far, you can ask, and then we'll take it from there. If you have any question concerning what we just did. Okay, Emmanuel, yeah, you are welcome. So nobody has a question concerning what we just did. So, all right. So if you don't have a question, it's fine. And this whole thing might seem very confusing and all that because of the codes and all that. But what I would advise is that if you really want to use this, or if you really want to use the R in your analysis, what you need to do is read and then practice, right? Because as it is now, even myself, every day, day in, day out, I'm finding new ways of doing things, right? Inside the R. Every day, new things are coming up. So I am learning continuously every day. So I don't know everything, right? But I know what I need to do. Once I open R and I want to do an analysis, I know what I need to do. And it is not by magic, it is practice and consistency. So if you really are interested in knowing what the R is. Okay, Brian, you have a question?
Yeah, just a quick one. Sorry to interrupt. So my question is on the outlier and then also the position jitter. So you mentioned that you can set the width to 0.1, right? So once you did that, it changed the spread. So the question is that how are you able to determine the correct width to actually use to control the spread? Then also on the outlier, looking at the plot we have right now, the box plot, you can see some points, I think around above 80, right? The
Yes.
end, yeah.
Yes.
So the one above 80 and I think 60, I don't know. Do they?
So all those points are outliers.
Okay.
But they
Because
were
when
not.
you apply,
So they were not brought in by the box plot. They were brought in
yes.
by the
So
scatter plot.
yes. So my point is that assuming I'm using the dot plot, right? As in the scatter plot, and then I plot it initially, and these appear. Because I noticed that once you brought in the outlier dot shape, it didn't affect that one. So how do you deal with outliers in the scatter plot itself?
Okay, so with the scatter plot, you need to do it manually. So you need to remove it from the data before you apply before you make your plot.
Okay.
Because the box plot is able to remove the outliers because of the way it is. So remember that I told you that. So when you do the scatter plot, right? When you do a scatter graph, R doesn't know that these points are outliers. It is you that is looking at it that knows. But when it draws a box plot, it knows that the points outside the whiskers are outliers, right? So because it knows that the points outside the whiskers are outliers, then you have a way of controlling it. But for a box plot, for all you know, that is what you want. So it cannot tell you that that is an outlier. So
Okay.
there's a
So just a
function.
quick one. How do I don't know, but do you have, say, a recommended way for dealing with outlier
Yes,
so you
yes. So
don't end
I
up
am coming.
you
I am
don't
coming to
end
that.
up engaging in what's called a p hacking?
Yes, so I am coming. I am coming to that. So
Okay.
to deal with the outliers, there's something we call I've forgotten the term, but there's a function that the box plot uses, right? So you add a certain value to the interquartile range.
Okay.
And then you when the values in your data set exceed or does not meet that value, then it means it is an outlier. That is what the box plot uses, right?
Oh, okay. Okay.
So there's a function for that. So you can apply that function to your data set, and then it will filter out those values from your data. So you can filter out for the plot sake, right? You can filter those values outside for the plot sake, or you can do winsorization. So winsorization is like you clip your data set to a certain value. So you see, let's say this 40 here, right? Let's say I want to clip my data to this 40 here. So here I am not removing the outliers. If I am clipping the data, if I am winsorizing, it means all this 80 and 60, I will clip them at 40. So although it is 60 and 80, I will change the values to 40 so that it fits the data. You get it? So here I am not
Okay.
removing the data. So it is called winsorization. But if you want to completely remove it, then you can filter those values that are deemed outliers from the formula. So there's a formula. I've actually forgotten the formula, but I think I can do that for you, right? You can apply it
Okay.
in your data set. So in the DPLY, there's a function called filter. So you can use it to filter out those values. And then the rest will be the values that are not outliers. And then you
Oh,
can
okay.
use that to draw your plot.
All right. Thank you.
Yeah, okay. So I think time is fast, man. It is 6 o'clock. So we spent a lot of time. So I would like to thank all that were
Um,
able to stay with us.
George,
Mhm.
George, um,
Yeah,
1 minute. I think the questionnaire is sent out for the registration. Someone actually asked an interesting question. But right now, this is an introduction, and as you said, you have to practice, right? Because once you are done with this particular session, and within a week or two, you forget everything you've learned so far.
yes,
So
yes.
someone asks if there's a course or like a recommended YouTube channel you can actually follow to learn more about this particular research tool after the webinar.
Okay, so what I recommend is there's a book, right? It is called R4DS, R for Data Science. So if you are really interested in learning data science with R, I recommend that you read that book. And then the institution that designs this R studio, they are called POSIT. They have a YouTube channel where I think mostly on Thursdays, or I think the first Thursday of every month, they post some videos on new things coming up in R. So you can check their YouTube channel. And then also at Elite Research and Data Science Institute, sometimes we host some webinars, right? Sometimes they are paid, sometimes they are free. But if you want to get an in-depth knowledge, then you need to join the paid ones. And then, as I said, I am part of the Ghana R user group, right? So for the Ghana R user group, mostly we do a lot of tutorials and then workshops for beginners. So you can join the Ghana R user group if you are not part. Let's see. Let me see if I can share the link. So the Ghana R user community, I can share the link with you so that you can join. So we mostly organize tutorials and workshops for beginners, right? So I'll put this in the chat. Okay, someone is asking for the YouTube link. Okay, so their name is Posit. So you can check, right? I don't know the YouTube, so let me see if I can. I don't know if so. Posit. So you can search for Posit like this. Yeah, so Posit PBC. I think this is it. So they also organize webinars and then they post it here, right? So you can check. Yes, yeah, you can check this workflows. So there are lots of our stuff. So if you want any R stuff, you can just search here R. You can just type R here, and then if it is related to R, you can look through and then workshop casual. You see casual influence with R, so you can look at this. And there are also, so you can just go on YouTube and just search for R, and then but these are like the legit people, like those that are, and then there's also the R consortium. Yeah, the R consortium. Let me see. R consortium. Yes, so our consortium, so they mostly deal with medical data analysis, right? So I think since you are medical students, I think you should just look at the our consortium. You see that I am subscribed. You should look at them. Mostly they do a lot of medical analysis there, right? Cleaning medical data with R. So, and then they are very, very practical, right? They are very practical. So since you are medical students, I think the R consortium will be good for you. All right, so I think that will be all. Okay. If there's nothing else, let me just stop sharing my screen. Okay, so Godfred, I think I am done, so you can give the vote of thanks and then we can end it. Hello, Godfred.
Hello, Sir George.
Yeah, so I think I am done now, so you can.
All right.
Yeah.
All right. Thank you so much, Sir George. We are much grateful for making time for this particular webinar. We actually scheduled this meeting for 2 hours, but then we've taken so much of your time.
Yes,
Thank you
yes.
so much, Sir George. God richly bless you. And to our participants, we thank you for making this meeting a success as well. I don't know if Saban is on the meeting, but then thank you once again for yesterday's web section. A lot of people came to my DM and their comment section that they were very, very grateful for the tutorial section he made for us yesterday. Okay, so on behalf of the Federation of Ghana Medical Students Association, we'd like to say very big thank you to Sir George. You didn't just teach us code, you showed us how data can tell story, reveal insights, and drive research forward. Many of us came into this session with little or no experience in R, but thanks to your clear explanation, hands-on examples, and patience, we now feel equipped to start exploring data confidently. You've helped remove the fear around programming and replace it with curiosity and enthusiasm. We truly appreciate the time, effort, and passion you poured into today's session. Thank you once again for empowering us with such a valuable skill. We look forward to learning more from you in the near future. And I know that the Ghana R community is organizing a symposium. I don't know if Sergio, you would like to hit on it before we close.
Yes, yes, yes. Yeah, so the Ghana User Group, we are organizing a conference, right? So I am a speaker at the conference. So I'll be talking about how you can apply machine learning to environmental monitoring. So I think that is part of my PhD work. So I'll just speak on that at the conference. So, if you like to, you can register for free. Registration is free, so you can register and then join online. Or I'm sure most of you cannot come to Tamale, so I think you can register and join online. So I don't know. I can share the registration link with you. I can share the registration link with you so that you can look at it. You can join online. So there will be a lot of renowned speakers coming. It will be very interesting. So it is being held on Thursday and Friday, yeah, 19th, and then this Thursday and this Friday.
Right.
So I'm sharing the link to register. So registration is free, but there are t-shirts. So I'm coming. I have t-shirts from the previous conference. So if you want the t-shirt, I think the t-shirt is 50 cedis, right? If you want the t-shirt, you can register and then pay 50 cedis for the t-shirts. But if you just want to join and then learn and then get some experience, you can register for free. Okay.
All right.
So yeah, that is that.
So with that said, I would like for if one could volunteer and give us a closing prayer.